Hello, Assalamu alaikum. We're starting a brand new block with a brand new topic. We're going to be covering areas around algebra for the quantitative section and sentence completion for the verbal section. The area of algebra that we're going to be focusing on today is age, so we're going to be doing age-related questions. And for the verbal section, we're going to be practicing sentence completion, starting from simpler questions, going to more difficult sentence completion questions in the later on videos. For both, we're going to be focusing on 10 questions. Now, because there isn't much new to the algebra questions and the sentence completion questions, probably you guys are doing something on a similar note during your school hours for the math and English classes. What we want to be focusing on is quality over quantity. So when we start, we're going to be doing 10 questions. When we start, I'd like you to keep a track of how many questions you got right and how many questions you got wrong. If you got them right, bravo, that's brilliant. If you did not get them right, why did you not get them right? Was it the concept that you did not know of, or was it a careless mistake, or did you just not think in that direction? So you want to be focusing more on quality than quantity, and focusing on why you are getting questions wrong, because there might be an underlying cause, and it might not be concept related. Most probably would not be concept related, because these are questions we've done before in school. Unlike arithmetic and analogies, which was arithmetic done years ago, which was information rusted, and analogy is not something we usually do at school. So let's start with the algebra questions. The first question we have over here is, so try and be ahead of me, pause the video, try and be ahead of me. Father is 4 times the son's age. So I would say, okay, father is 4 times the son's age. After 8 years, so 8 years after, he would be 2.5 times the son's age. So because they're saying after 8 years, I would think, okay, if f is the father's age, after 8 years, it would be f plus 8. So that age would be 2.5 times the son's age. The son at the moment is s. After 8 years, he'd be plus 8. So that would be the age of the son. 2.5 years later. Now, I do know 2.5 looks like this, but I'm not very comfortable placing it in my equation because it's a decimal. Not very comfortable working with decimals. So what I would do is I'll rewrite it as 2.5, which I would again rewrite as a normal fraction. 2 times 2, 4. 4 plus 1, 2 times 2, 4. 4 plus 1, 5. 5 over 2. So again, after 8 years, the father would be 2.5 times the son's age. So 2.5 comes over here. 2.5 times the son's age. That's the equation that I want to be working on. Let's see. Let's take a look at the final question. What did they want? I've got 2 equations actually. I've got this one here and I've got another one over here. After further 8 years, how many times would he be the son's age? So after further 8 years, how many times would he be the son's age? That means once I do find out the father's age and the son's age, what I want to do is, because they're already 8 years ahead, and then they want another 8 years, so I would say, okay, father's age plus 16, and son's age plus 16. That's what I want. That's what I'm looking for eventually. But I need to work out the father's age and the son's age. What could I do? Well, first of all, I would try and convert everything into, I can't work with it. I have one of them f and the other one's an s. I need the exact same variable everywhere, so 4s I'm going to replace. Instead of this f over here, I would replace it with 4s because I know that they're both equal. F is equivalent to 4s according to the first equation, which is the information that I would replace in the second equation. So instead of f, I write 4s plus 8 equals 5 over 2 s plus 8. Everything else is just carrying on. Continuing. So that's continuing. So what I would do, how can I work it out? I mean, I can multiply the 5. Let's multiply, let's open up the brackets. 4s plus 8 equals 5 is multiplying in with the s, and 5 is multiplying in with the 8. 5 times s is 5s, plus 5 times 8 is a 40. The entire thing is being divided by 2. Although I can write it separately, divided by 2, because even the 2 is being divided by s and is being divided by 8. I can do that as well. I'll be a lot more comfortable if I just write it down as one thing, because that way I can just take it to the other side. 2. So because it's being divided by 2 over here, I want to take it over the equals to. Remember, over the equals to, if you're changing around anything, the operation reverses. At the moment, it's division, so on the other side goes multiplication. So it's going to be 2 times 4s plus 8 equals 5s plus 40. 2 times 4s is 8s. 2 times 8 is 16 equals 5s plus 40. S is on the same side, the regular numbers on the other side, so I'll bring 5s over here. It has a positive sign. When it comes to the other side, it becomes negative, negative 5s. 16 is a positive here. When it goes to the other side, it becomes negative. So I end up getting, I'm running a bit short on the space, I end up getting 3s, because 8 take away 5 is 3, equals 40 take away 16 is 24. 3s equals 24, and then I divide both sides by 3 to get rid of this 3, and I'm only left with the s. 24 divided by 3 is an 8. So now I know that the son's age is 8. Coming back to what I left over here, I know that the son is, because they said what they were interested in, the son's age is 8, right? What they were interested in after further 8 years. So already, let's say you're in this time zone. So first of all, they said after 8 years, that's plus 8, which is what we had here. And then they're saying after another 8 years, what would be the comparison with the ages? That means I'm going to be adding a 16 into both of them. Son I know is 8, plus 16, that's 24. So I know that the son is 24 over here. And the father is 4 times the son, right? The father is 4 times the son. That's 8 times 4, 32. But remember, we had to add the 32, and I'm going to be adding a 16 into it. That makes it a 48. So the father is 32 plus 16. That's a 48. They're saying after further 8 years, how many times would he be? After further 8 years, how many times would he be son's age? And is that double? 24 times 2 gives you 48. Is that double? So we go like 2 times. That's it. Can you tell the questions are getting a bit tougher? In terms of, I mean, the earlier questions were a bit simpler. Mind you, like a lot of time is being taken because I'm explaining it to you, you know, and we haven't done the concepts of the basics of algebra. So that's why it's taking a bit more time, but we get used to it because we've got another 9 questions to work on. So we will manage. Let's go next question. The sum of ages of 5 children born at the interval of 3 years each is 50 years. So it's basically a sum of 5 ages. So we've got 5 ages, actually. The first one, I don't know how much it is. Let me just say x. Then the next one would be, because the interval is 3 years, so the next one would be, could I say x plus 3? That's 1. That's 2. How many do we have? That's another 3 after another 3 years. That's plus 6. Does that make sense? So if one person is, let's say, 2 years old, after 3 years, that's 2. He would be, the next one would be 5. The other one would be 8. So you're adding 3 on every time. So that's 3 kids, the 4th one, and the 5th one. So we've got 5 kids. The sum of their age is 50 years. What's the age of the youngest child? So that's easy to do. Do you see in age-related questions, you're formulating an equation and then solving it. That's it. So step 1 is formulating an equation. You have to make sure you get that right, and then the rest of it is just solving. So what I would do is put the x's together. So I have 1, 2, 3, 4, 5. X plus x is 2x, right? So x plus x plus x plus x plus x, which would be 5. X plus 3 and 6, that's a 9. 9 and 9, that's an 18. 18 and 12, that's a 40. That's a 30. 18 and 12 is a 30. Equals to 50. I'll take 30 to the other side. It's being added here. On the opposite side, it becomes subtraction. The sign reverses. It's 20. 5 times what gives you a 20? 5 times what gives you a 20? I'll divide both by 5. So they cancel out. I'm left with x only. 20 divided by 5 is a 4. X equals to 4. So that's the age of the youngest child. That was the age of the youngest child, right? So we got a 4. That's the answer. It was fairly simpler, maybe. Third question. A father said to his son, I was as old as you are at the present time of your birth. So let's say the son is born. Which means he's 0 years, right? At that time, the father is, I don't know how much, let's just say x. The father is x years and the son is 1 year 0. And then they're saying, the father said to his son, not when he was born, obviously, the father can't be 0 years then, after a certain period of time, he said, I was your age when you were born, which means x years have passed now. Let's say if he was, I don't know, 25, the son's 25 years old and the father goes like, son, I was 25 years old when you were born. Makes sense, right? So basically, that's the same number as the amount of time that has passed already. So, after x years, so now the son is x years. How old would the father be? X years have passed, which means double, so he's 2x. And then what they're saying is that the father's age is 38 years now. The father is 38 years now. What's the son's age? 5 years back. So when we get the son's age, we just subtract 5 from it. So 5 years back. 38 equals 2 times x. 2 times what gives you 38? You can divide 38 by 2, and that would give you a 19. So the son is 19, and they're saying 5 years ago, how old was the son? He was 14. That's it. Next question, question number 4. A is 2 years older than B, who is twice as old as C. So we've got A, and we know that A is 2 years older than B. So A is 2 years older than B. And then they're saying who is, which means B is twice as old as C. Twice as old as C. If the total of their ages A, B, and C be 27, so the sum is 27, how old is B? Okay, from these two equations, the information that they had given you had to be transformed into equations. That's the only way we can solve algebraic questions, unless you use common sense, unless you've got a sharp common sense and you do the plus minus in your head, and that's how you got it. Theoretically, this is the only way we can solve questions like these. Now, what I'm thinking is they're telling us that A, B, and C are all together 27. I'm thinking, no way can I solve that equation unless everything's in the same format. I mean, I can have everything in terms of A, or everything in terms of B or C. But the minute I take a look at these two equations, I recognize I can have equations in terms of B, because over here I can write, it's given actually already. Over here I can say A equals 2 plus B, so instead of the A I can replace it with 2 plus B. That A can be written as 2 plus B, right? Plus, that B would just follow down the way it is because we're making everything in terms of B, and that is already in terms of B. C, I need to follow that down, but I need to get it from here. Now what I can do is take 2 to the other side, so it would be B over 2 is equal to C. 2 is multiplying here, we divide on the other side. B divided by 2 is C. So instead of the C, I can rewrite it as B over 2 equals 27. And now I have everything in terms of B. I can solve this equation. What I would do is take the 2, take this 2 to the other side, which means it would be minus, right? So I've got B plus B over 2 equals 27 minus 2, which is 25. B plus B is 2B. Actually, I've got 1B, 2B, half B. Can I say that? I've got 2B plus B over 2, right? Can I add them? See, I don't know how clear it is. Let's do it here. We know it's 25, and I have a 2B here, and I have a B over 2. Let's do it here. So I have a 2b plus b over 2, that equals 25. I can't add these two because one of them's got the denominator of 2. To make the denominator 2, what I would do is divide both by 2. So I have 4b over 2 plus b over 2 equals 25. If I add them, 4b plus b, that's 5b over 2 is 25. Multiply by 2, so I get rid of it from here, and I'm left with 5b equals 25 times 2, 50. So b equals 10. Because 5 times 10 gives you 50, right? So I got b equals to 10. How old is b? Well, b is 10 years of age. That's it. Done. Let's go on to the next question. b equals 10. I'm going to erase it because accidentally I went to the next question's area. Okay, next question, question number 5. A man is 24 years older than his son. A man is 24 years older than his son. In 2 years, his age will be, so after 2 years, we've done something like this before, right? After 2 years, his age would be, the son would also be plus 2, right? After 2 years, the age would be twice the age of the son, twice the age of the son. The percentage of age of his son is, the present age of his son is, first of all, can I find out S and the son's age and the man's age? Because now I do know that M equals to 24 plus S. I'm going to replace this M with 24 plus S, replaced, plus, copying that down, plus 2 equals 2 times S, plus 2 times 2, 4. That's 24. 24 and 2, that's 26. I want to bring the 4 to the other side as well, because it's positive there, it becomes minus, equals, I have a 2s here, and I bring this s to the side as well, so it would become minus. The operations always reverse when you take anything from one side to the other. 26 take away 4 is 22, equals 2s take away s is just an s. So I got s to be 22. The present age, we did consider the present age of the son to be s, which is what the answer should be, 5D. Done. Next question. The sum of the present ages of the father and his son are 60, okay? So father and son, both, the sum of both is 60. 6 years ago, father's age was 5 times the age of the son. 6 years ago, that means father take away 6 years, son take away 6 years. 6 years ago, father's age was 5 times the age of the son. Father's age 6 years ago was 5 times the age of the son. That's S. And then, after 6 years, son's age will be what? So once I get S over here, they're saying after 6 years, so I would do, okay, S plus 6, that would give me the answer. Let's work it out. Can I rephrase this one here and go like, F equals to father equals, 60 take away the son's age, so that I have something to put in here. That F, which is equal to 60 minus S, goes in place of F, so it's 60 take away S in place of F. Copy down the rest, minus 6 equals 5S minus 30. 60 minus 6, that's 54. I'll bring 30 to this side as well, plus 30. I want to take S's to one side, so that's 5S plus S. That's a 4S. 54 plus 30, that's 84. 84. 4 times the son's age is 84. 4 times the son's age is 84. 4 times 14? 4. So the son is 14 years of age. We've done the table of 4 already. So the son is 14 years of age, because 4 times 14 gives me 84. So now that I know that the son is 14, because they said after 6 years, and we decided to add 6 into the son's age, that is a 20. So after 6 years, the son is currently 14. After 6 years, he's going to be 20 years of age. Next question. Aisha's father was 38 years of age when she was born. Okay, so Aisha is 0, and the father is 36. While her mother was 36 years of age. Okay, the mother is 38. Father is 38. The mother was 36 years of age. The father is 38. The mother is 36 years of age. When her brother, 4 years younger to her, was born. So the brother was 0 when he was born. How old was Aisha? Her brother 4 years younger. So Aisha must have been 4 years of age when the brother was born, right? What's the difference between the ages of both the parents? Now, basically, this is in a different time zone, and this information is in a different time zone. Can we convert them both to the same time zone? Because when Aisha is 0, the dad's 38. When Aisha is 4, how old should the dad be? When Aisha is 0, so you added 4 into it, now she's 4 years old. After 4 years, how old is the dad? He's 42. So the father is 42. And they're saying, what's the difference between both the ages of both the parents, the mother and the father? Well, 42, take away 36, that's a 6 years of age gap. 6 years of age gap. Do you see how they're combining algebra to age-related questions? And these are the kinds of questions you could be dealing with in your present everyday life. I mean, there's nothing too mathematical about it. Next, question number 8. Present ages of Sama and Anan are 5 to 4. 5 to 4. Okay, over here you'd like to pay attention because question numbers 8, 9, and 10 are slightly different to what we've been doing. Reason being, they're introducing ratio into age-related questions. Again, you're always like, it's preferable that you give it a try yourself before catching up with the workout. So there are 2 people, Sama and Anan. The ages are 5 to 4. 3 years hence, that's 3 years later, the ratio of the ages will become 11 to 9. 3 years hence, so 3 years from here, the ratio of the ages will be 11 to 9. What is Anan's present age in years? One thing we want to understand is, if, for example, someone goes like 100 to 50, that could always be simplified. Divide both by 50, you get a 2 to 1, right? That could be simplified in here. Ratio is always in the simplest form. That means not necessarily Sama's age, she's 5 years old and Anan's 4 years old, but that's the proportion of their age. It could be that maybe it was 10 and 9, 10 and 8, and they simplified it to 5 and 4. Maybe it was 50 and 40, and they simplified it to 10 and 4 divided by 10. So we don't know what they've simplified it into. We don't know how they simplified it, but we do know that eventually what they're ending up getting is a 5 to 4. Which means, would I be right to say that this is probably a multiple of 5 and this is probably a multiple of 4? Maybe they multiply both numbers by 2, by 10, by 100. We don't know, but they are a multiple of 5 and 4. Now, if we got that part, now I know what I'm going to try and compare is, I would say, okay, 3 years later. So they're talking about 3 years later. That means it's 5x, the age at present, plus 3 years. Plus 3 years, 3 years later, would be the same thing as 4x. No, actually. I could better write it as a... Basically, I'm trying to get this one in the numerator, that one in the denominator, because that's how we write them in ratio. That's 4x plus 3. 4x plus 3, right? That's 11 to 9. Let me write it on the other side. So I can rewrite it like this. I can rewrite it as a fraction, right? That ratio that I got over here, 5x over 4x plus 3, would be the same thing as this ratio here, which is 11 over 9. Because this is taken from the present age and then converted it into an age 3 years later. That's why we added the 3 into 3 years later. Present age converted it into the later age, which is 3 years later. But this on this side is actually what the age is after 3 years. Here, 3 years, hence the ratio of the ages will become 11 to 9 respectively. So this is from the present age. From the present age over here, what we've done is we've tried and made a algebraic equation to go to the future after 3 years. So this is plus 3 years. This is what we end up getting. All I need to do is just work it out, simplify it. I would cross multiply. I would say 9 times 5x plus 3 is equal to 11 times 4x plus 3. All I would do is now just simplify. 4x plus 3. That's 9 times 5 is 45x, plus 9 times 3 is 27. 11 times 4 is 44x, plus 11 times 3 is 33. That's an x. X is on the same side. 44, take away 4x. 40x. Regular numbers on the same side. How come regular numbers on the same? That's 45. Oops. That over here, 9 times 4. Okay, hold on. To do it. Hold on, because I accidentally did something wrong. So 9 times 5 is 45x. 9 times 3 is 27. 11 times 4 is 44x. 11 times 3 is 33. I'll bring this 44x to the other side. So I've got 45x, take away 44x equals 33x, take away 27x. So that's just an x equals 33 take away 27 is a 6. 33 take away. So I got the value of x for 6. Now, what was 6? What's the question again? What is Anand's present age in years? So Anand's present age is this one. It's 4x. So we bring it back. 4x, which is 4 times 6, which is 24. This one over here. So that's it. That's how we work this out. It might be, if, for example, this kind of question is a bit new to you, you might want to go through the workout one more time, rewind the video, go through it one more time, because because it's new, you have to go through it one more time because it's new, and the next question number 9 and 10, are going to be a replay of something similar, so we would get used to it, inshallah. Let's go take a look at question number 9. 6 years ago, the ratio of the ages of Queenie and Sag was 65, so it's 6 to 5. That's 6 years ago, mind you. 4 years later, so you're here at the moment. 6 years ago, this was happening, but then 4 years later, this was happening. That's the situation. Just keep this in mind, because that's where they try and trick you into moving backwards and forwards into the timeline. So 4 years later, the ratio of the ages will be 11 to 10. What's Sag's present age? That's the question. Now, the ratio 6 years ago. So 65 is the ratio that they have over here. 6 to 5 is the ratio that they had over here. 11 to 10 is the ratio that they have 4 years later, which is in this period they have the ratio 11 to 10. Right? What's Sag's present age? We will come to that. This is where the question lies. What is Sag's present age? But let me try and form an algebraic equation similar to what I did in the previous question. What I would do is, I know that this is a simplified version of something, so I can rewrite it as 6x plus how much? Because, okay, I can write it as 6x and 5x, right? Step by step. I can write it as this is a multiple of 6 and multiple of 5. But if I'm planning to take this thing into the future, what I would have to do is add a 10 into it. Why am I adding a 10? Because, well, from here to here it's a 6, and from here to here it's a 4. So that's a total of 10 years. Which is why what I would say is, okay, the previous age plus 10 over that's Queenie's age, this one is Sag's age, plus 10 should give me the later age, which is 11 over 10. That's it. That's how you form the algebraic equation. Once that's done, it's straightforward math because you just cross multiply. So what I have is 10 times 6x plus 10, and cross multiply 11 times 5x plus 10. That's what I have. 10 times 6 is, I'm having to move backwards. Let me go here. 10 times 6x is 60x plus 10 times 10 is 100 equals 11 times 5 is 55x plus 11 times 5x is 55x, 11 times 10 is 110. Bring everything to the same side, regular numbers, x numbers here, so that's 60x take away 55x, that's a 5x, and it's 110 take away 100, which is only a 10. Let's divide both sides by a 5, and I end up getting x as 5. Okay, now that I know x is 5, what was x once again? Now that I know x is 5, oh, hold on, that's 2. What did I do? This thing here, 10 divided by 5 is a 2, right? X is 2. Now that I know x is 2, what I would do is, I know that, this is, what am I interested in, by the way? I'm interested in Sag's age, which is the second one here. So that second one is here, and that second one was converted into 5 times x, which is 5 times x, which is 2. From here, that's a 10, right? So, the age of Sag is 10 over here. What they're interested in is what's the present age. Do you remember this was the current age? This was 6 years earlier, that was 4 years later. To get the present age, all I need to do is add a 6 into it. 10 and 6 would give me the present age of Sag, which is 16. I hope it's clear, and let's move on to the next question using the very similar concept, exactly the same concept actually. So let's try. The present ages of 3 persons in proportions 4, 7, and 9 are in proportions 4, 7, and 9. 8 years ago, the sum of their ages was 5x. So we know that this isn't the exact age. Actually, the age is supposed to be 4x, 7x, 9x, right? These are the ages. But what they're interested in is 8 years ago. That means I would say, okay, 8 years ago, so I'll subtract 8. 8 years ago, 8 years ago. The sum of their ages was 54. So when you added up everything, 56. I'm reading everything wrong today. So the sum of their ages is 56. 7x, 4x, 7x, and 9x. Let's add them all up together. How much you get? That's 16. And 4 more, that's 20. 20x. Minus 8, minus 8, minus 8. I'd rewrite that as minus 8 times 3, 24. equals 56. Take the 24 to the other side. It's a subtraction here, so it becomes addition on the other side. 24. 56 and 24 gives me 80. 20x equals 80. 20x equals an 80, which means x is a 40. Right? Coming back to what did they want? They were saying x is a 4. Oh, really not a good day to be doing this recording. X is 4. 80 divided by 20 divided by 20. X equals 4. Now that I know x equals to 4, what do they want again? Find the present ages in years. This was the present age, right? This was the present age. Now I know x is 4, so I would say 4 times 4, 16. I don't even need to go back, go forward, because I know this is 16. Just to double check, 7 times 4 is 28. 9 times 4 is 36, so that's it, that's my answer. I hope you're okay with the algebraic questions, because this is the first class for the algebraic section. It might be a bit overwhelming. No problem, go through the questions one more time, and so that you're ready for tomorrow's class on algebra. Let's move on to the second part. So we're looking into the second part of this class, which is sentence completion. What you want to be doing is trying to work it out before we go forward and before we look at the answer, or before I tell you the answer. Because sentence completion is something we've been doing in the classrooms, we're not going to be going into the basics of it, just practicing. So you'd realize today's questions are a bit easier than tomorrow's and the day after. So we're going to be just working on the difficulty level, really. Let's take a look at the first one. You may wonder how the expert on fossil remains is able to trace descent through teeth, which seem dash pegs upon which to hang whole ancestries. So can you tell that they're talking about two things in opposite directions? So what I understand is they're saying, okay, you're deciding upon wherever the previous things are coming from, you're deciding upon the descent through teeth. I mean, that's a very small piece of the entire living creature, right? So they're saying, this is what I understand, which seems dash pegs upon which to hang the whole ancestries. So that means that you're working on something, you're hanging upon, that's why they use the word pegs, you're hanging the whole entire ancestries onto that small thing. So it's reliable, maybe it is reliable, but it's not enough. That's a very small piece to be doing experiments and judging upon, because what you're actually talking about is a huge living creature. So inadequate looks okay. Inadequate looks okay because the information that we have is very small compared to what we need in actual. Novel doesn't make sense. Suspicious doesn't make sense at all. So it could be, it is inadequate because what they're trying to say is that the information that you're trying to peg the whole situation about, the whole ancestries about, is quite inadequate. What I've done is there is explanation underneath every question, just like we did for analogies, so you can go through it. Next question, we've got, seeing the pictures of our old home made me feel dash and nostalgic. So from nostalgia, you can relate that seeing the pictures of the old home made them feel not very happy. And plus, because we know they're looking into the past, this word alone is enough for us to know, because wistful means you're sad about something in the past. So from nostalgia, we know that they're not something that they're very happy about, and from the old home, we know that it's in the past. Wistful, straight away, there is no doubt in this particular thing. Then question number 3. Book publishing has long been dash profession, so it's been some sort of a profession. Oh, where are the examples? It's been some sort of a profession. Partly because for younger editors, the best way to win a raise or a promotion was to move on to another publishing house. Okay. Innovative, prestigious. Itinerant. Rewarding, so I catch this one because they've used move on to another publishing house. Partly because for younger editors, the best way to win a raise or promotion was to move on to another publishing house. And itinerant means exactly that, because this is where I got the answer from, because they're saying move around, and to move or travel from place to place is what this is, so it's an itinerant profession, where you can move around from one place to another. Okay, next. Part of the confusion in our societies dash from our pursuit of efficiency and economic growth, in the dash that these are the necessary ingredients of progress. Okay, part of the confusion in our society, dash from, stems from, derives from, emerges from, extends from. Emerges looks right to me, because part of the confusion in our society, dash from. So this is something that's already happened. Stems goes out, and derives is also something that goes out, because something already happened. And extend goes out. I'm going to go with C. Let's just double check with the second line. From our pursuit of efficiency and economic growth, in the dash that these are the necessary ingredients of progress. In the consideration that these are necessary ingredients of progress. Let's go with C. Okay, then next, we've got question number 5. War has been, throughout history, the chief dash of social cohesion, and since science began, it has been the strongest dash of technical progress. Okay, so we're looking into question number 5. War has been, throughout history, the chief dash, the chief reason, the chief origin, the chief cause, the chief source. They're talking about history, right? The chief reason of social cohesion? No. And since science began, it has been the strongest to the technical progress. Encouragement? No. Because it's based in history, I'm going to go with source. Incentive. And especially because they said throughout history, because they're specifying throughout history, so they're not talking about one particular event that would be a cause of something, or an event that originated from something, or a reason of an event. Because they're talking about throughout history, source is most applicable. War has been throughout history the chief source of social cohesion, and since science began, it has been the strongest incentive to technical progress. Because the second words have similar meanings, these actually, and the second words have similar meanings, but it's the first one, because they said throughout history, that gave out the answer. So because causes of a particular event, origin is a particular event, reason is of a particular event, but throughout history could be the word that I'm going to go with, the source. Next question. Philosophical problems arise when people and questions that, though very dash, have certain characteristics in common. Philosophical problems arise when people and questions that, though very dash, have certain characteristics in common. So, though very dash have certain characteristics in common, that indicates something in opposition, something the opposite of each other. So having characteristics in common, this should be sort of the opposite: relevant, elementary, abstract, diverse. How about diverse? Because if having diversity is the opposite of having something in common. So diversity is to have a variety, and having something in common is one or two things. So we can go with D, because they are the opposites of each other. Having diversity is the opposite of having things in common. You can take help from the explanation given if it's not very clear. Question number 7. Oh, why am I showing the answer? Question number 7. The ambassador's papers are not dash reading, but on who reads slowly and attentively will be richly repaid. So it is something that is of importance. Can repay richly, given the condition that you read slowly and attentively, which means petty. If it's petty, it's not something that's richly paid. Valuable, insightful, easy. Are not dash reading, So they are not valuable, no, they have to be valuable because they are richly repaid. Are not insightful, they have to be insightful if they are richly paid, so not that. They are not easy, maybe yes, they are not easy reading, but if you read slowly and attentively, you will be richly repaid. So let's go with D. Next, question number 8, that's the explanation for D. Question number 8, let's move on. 3 more to go. Question number 8. Although the substance is normally quite dash, scientists found that when tampered with other elements, it could be stored safely in metal containers. So those of us studying chemistry at school, this would make sense. And what's the answer? Otherwise, what they're saying is tempered with other elements, it could be stored safely. So that means it can be stored safely if it is tempered with other elements, which means otherwise it's not safe storage. It's not safe to store it. Caustic, because when something is caustic, that means it burns or corrodes by chemical action. So it's something caustic that burns or corrodes by chemical action. So we go with caustic. Next, question number 9. There is some dash. The fact that the author of the book, as sensitive as informed as Indian artisans, did not develop her interest in Native American art until adulthood. So that's a contrast, because although she is in a particular, that's a contrast for she grew up in a region rich in American Indian culture. So, irony, sophistication, doubt about, concern about. There is some irony in the fact that the author of the book, as sensitive and informed as Indian artisans, did not develop her interest in Native American art until adulthood, but she grew up in a region rich in American Indian culture. So there's an opposition, there's an irony in this particular thing. Let's go with A. Question number 10. It is ironic and somehow tragic that good people are often dull, while evil people can be endlessly dash. So there's an opposition again. Good people are dull, while evil people can be endlessly the opposite. Dull, ordinary is the opposite. Stubborn is the opposite. Skeptical is the opposite. No. Fascinating is the opposite of being dull. So let's go with option D. That's it. We're done with today's lesson. So we're done with today's lessons. I'll catch you guys tomorrow. What I would like to remind you is to make sure that you add up new words into your vocab journal. Take anything from today's lesson that might be of value, and go keep up with the tables as well. We've formulated a habit of going through the tables and vocabulary. Keep that up. Until then, see you tomorrow. Until then, keep shining.